Good morning to all, and today we will discuss about calculation of the branch voltages and branch currents using Constraint matrix for this particular given network. What is the requirement of this Constraint matrix? We have to represent all these branches in terms of the admittances. This is 1 ohm is the impedance or resistance, maybe this half ohm is 1 by 10, this is 1 ohm, this is 1 by 4, and this is 1 by 4. At the same time, we have to represent each branch in terms of the current source. Is it right? So first what I will do, I will convert this voltage source into the current source as well as this voltage source into the current source first. And after that conversion, I will represent each impedances in terms of the admittances, and then we are in a position to prepare its graph, and then we will do the remaining calculations. So here in this case, our first step, that is step number 1, is conversion of the figure into the standard format. This is the point number 1. Now what I will do, I will copy this as it is, converting the current and voltage sources. Converting voltage sources to current sources. This conversion I will do first, and I will redraw the figure. This is 1, 2, this is the third point, and it is the fourth point. I will keep this resistance as it is, this, as well as I will keep this resistance as it is, which is something like this. Here, this voltage source I will convert into the current source. This is the voltage source which I will convert into the current source. Its conversion is something like this. I will discuss about this conversion later on. At the same time, I will convert this voltage source into the current source. That voltage source into the current source again. This here, that figure will be something like this. At the same time, I will keep this resistance as it is, which is 1 by 10 ohm, this resistance as it is. And finally, I will redraw this outer figure or outer resistance as it is. This resistance as it is. This will be the figure. Its value is 1 by 4 ohm. Its resistance is 1 ohm. Its resistance is 1 by 4 ohm. This is 1 upon 10 ohm. Its resistance. This resistance is half, that is 1 by 2 ohm. This resistance is 1 ohm again. And we are converting this voltage source into the current source. Then how much its value? I is equal to V upon R. This 12 upon 1 is nothing but it is the 12 amperes. This is 12 amperes. And how is this direction? This positive terminal is upper side, which is direction is the upward direction. Is right. At the same time, I am calculating the value of this current source also. Its direction is downward. This direction is downward. Its value is V upon R. That is 5 volt upon 1 ohm is nothing but it is 5 amperes. Is it right? Just what I have done, I have converted this voltage source into the current source. At the same time, I have converted this voltage source into the current source. Otherwise, everything I have kept it as same. Remaining everything is the same. Now what I will do, now I will convert all these resistances into the conductances, or all these impedances into the admittances, and we will represent in the standard format. We will represent this figure in standard format. Standard format representation. We will represent all this figure in standard format. How it will be? The figure will be the same. Just here we have to convert these impedances into the admittances. Means it will be figure something like this. This is the second point. This is the third point. and it is the fourth point. Is it right? Now here in this case, this resistance I will keep as it is. This is resistance. Again, this resistance will be the same. This will be the same. Its values are going to change. Its values are going to change. I will discuss those values. Here again, this resistance is also same, and this outer part, which is this branch, again it is the same. That is as it is. At the same time, here is the current source. The current source will be again same, which is of the 12 amperes, which is upward direction. This is 12 amperes. Here is again another current source, which is downward direction, which is also same, and it is the 5 amperes. This is 5 amperes. Now, whatever the impedances are there is reciprocal. I will represent here 1 by 4 ohm. Means in this particular case, it will become 4 mho. 4 mho or 4 Siemens. Is it right? This is 1 ohm. Its reciprocal will be 1 mho. This is 1 mho. It is 1 by 4 again. This value will be the 4 mho. This is again 1 mho. And this value 1 upon 10 ohm, it will become 10 mho is the resistance of that branch. And finally, it is 1 upon 2 ohm, it will become 2 mho. These are the representations. Is it right? Now here, in this case, we have taken this figure. Now this is our standard figure. And for this particular standard figure, first I will mark the nodes. If you have any difficulty, please raise your hand. This is one node. This is another node. This is the third node. And this is the fourth node. These are the nodes. I will give some names to the nodes. This is A node. This will be the B node. This will be the C node. And finally, it will be the D node. Just I have given some names to the figures. At the same time, I will assume the name of the branches. This will be the branch number 1. This is the branch number 1. Next is the branch number 2. Here, this branch is the branch number 2. Here it is the branch number 3. This is the branch number 4. And this branch is the branch number 5. And here, this branch is the branch number 6. How the names I have given? Branch number 1, branch number 2, branch number 3, branch number 4, branch number 5, and it is the branch number 6. These are the names which we have given to this particular figure 1, 2, 3, 4, 5, and 6. Is it right? At the same time, I will assume some suitable directions here. In this particular case, direction of this particular current, I will assume it as a downward. There is no restriction. You can assume any direction. This may be the downward or upward or anything. At the same time, I will assume this direction also downward. Similarly, for the next branch, I will assume its current downward. This is the current which I will assume downward. This current, again, I will assume it has a downward. At the same time, the current in this particular branch number 4, I will assume it as upward. Just I am assuming random directions. And finally, I will assume the current in this particular branch as towards the left hand side. This is 1, 2, 3, 4, 5, and 6. We have assumed the 6 directions. Now, based on this assumed directions, now we are in a position to prepare its oriented graph. And from the oriented graph, we are in a position to select a tree and we can do the remaining calculations. Is it right? Now here, in this case, just I have taken the random directions of the currents, and based on these random directions, we will prepare its next point, which is nothing but the oriented graph. I will write here, third point, preparation of the oriented graph. Preparation of oriented graph or directed graph. This is oriented graph. We will prepare its oriented graph. Now here, while preparing the oriented graph, just I will mention the nodes first and then we will work out on the calculations. This is one node. This is the second node, which we will assume. This is the third node, and next is the fourth node. These are the 4 nodes we are assuming in this particular case. Is it right? I will name to this node, this is node A. In this particular case, this will be the node B. Here it is the node C, and finally it is the node D. The same names I have repeated: A node, B node, C node, and D node. Is it right? Now here we will connect the branches. Here this is the branch number 1. This is the branch number 1. I will connect the branch number 1 here between the A and D. This is the branch number 2. Here it will be the branch number 2. Next is the branch number 3. This is the branch number 3 which we have shown. This is the branch number 4. This is the branch number 4. This branch is the branch number 5. And last we have this outer side branch which I will show something like this, and that is the branch number 6. In this particular case, this branch we have which is the branch number 6. Is it right? Now I will give the name to the branches as well as I will assume its direction of the current. In this case, its current of the branch number 1 we have taken it as a downward, which this is downward, and this branch is the branch number 1. The second branch, its current is we have taken it as a downward, and this will be the branch number 2. Its current we have taken again downward, and this is the branch number 3 we have taken. Its current is a downward, and this will be the branch number 4. Again here this current is downward, and this is the branch number 5. And finally for the branch number 6 we have taken its current opposite direction, and this is the branch number 6. This is the preparation of the directed graph or oriented graph. Sorry, I will do the correction. This branch number 4 is direction we have taken it as upward. That's why its direction is upward. Because in this case I have shown it as upward, this should be the upward. You see here in this particular case, these two currents are downward, this is upward, this is downward, and this is downward, and this is towards left hand side. These are the directions. Otherwise, if you have taken this as a downward also, then also use the same thing in the calculation and complete the calculation accordingly. Now here, if we have converted the given figure into the all sources into the current sources, then all impedances into the admittances, and then we have drawn its oriented graph or its directed graph. Then I will go to the steps in which we are trying to discuss or the steps for the calculation of the voltage and current by using this particular approach, which is nothing but the concept. I will show that slide and I will come back again. Now look at here, what is the first step? In this particular first step is, in this particular case, the first step is draw the oriented graph of the given network. We have drawn. Now select the tree and prepare the fundamental cut set matrix, that is QF. Sometimes in the problem itself they will give the tree. If it is not given, then we can select the tree of our choice. If it is given, whatever the tree which we have given with us, then we have to select that particular tree and we have to prepare its graph, which is that is cut set matrix, and then we have to find out that is a QF. I'm coming back to this point again. Now here in this particular case, if I'm coming to this particular point, the next step is the step number 4, which I will discuss here. The next step is the step number 4. Look at what is the step number 4. Step number 4 is selection of the tree. First, select the tree and prepare its cut sets first. Selection of tree. Selection of tree and preparation of cut sets and cut set matrix. Which is fundamental, or I will write here fundamental cut set matrix. Preparation of the fundamental cut set matrix. Is it right? For that purpose, I will take the reference of this figure and we will draw that particular portion. Look at here. This is the oriented graph which we have prepared. And to begin with, deliberately, I will assume little complicated tree, because if the complicated tree is given in the examination, you must be in a position to find out its solution. That is the motto behind that. In this case, this is node A. it will be the node B, this is the node C, and finally it is the node D. What I will do, I will select little complicated tree in this particular case. I will select little complicated tree. This how will be the tree which I am selecting? I am selecting this branch, then this particular branch and this branch as a tree, which branch number 6, branch number 4 and branch number 5 as a tree. I am selecting the branch number 6, branch number 4 and branch number 5 as a tree. If we are doing that, this is the branch number 6, this is another branch and this is another branch. We are selecting this as a tree. We are selecting this as a tree. Is it right? Now here if we have taken this as a tree, what are the remaining branches? Otherwise I will give the names to these branches first. Its direction is backward, which is the branch number 6. Its direction is upward, which is the branch number 4. Its direction is downward, which is the branch number 5. This branch number 4, 5, 6, branch number, this is 4, 5, 6, it will form the tree, because what is the definition of the tree? It should connect all the nodes directly or indirectly without forming the loop. Now here is no formation of the loop, that's why that is a tree, valid tree. Then here, I will draw the remaining branches. This is one branch, this is another branch, and this will be the remaining branch. In this case, this branch is the branch number 1, which is the core tree. This is the branch number 2, its direction is downward. This is another core tree branch. And next is the branch number 3. This is the branch number 3, which is another core tree branch. Is it right? Now what I have done, I have selected as a tree, and first we will prepare the cut set and then we will prepare the cut set matrix. Just I have taken the same figure here, but just I have shown this one, branch number 6, branch number 4 and branch number 5 as a tree, and remaining are the core tree branches. Is it right? Now here if we have selected that particular branch as a tree, and now we are in a position to prepare the cut sets. Now what is the fundamental cut set? We have to prepare the fundamental cut set. Otherwise I will write here also, that is nothing but fundamental. Fundamental and preparation of fundamental cut sets. Not here, this is the preparation of the fundamental cut sets. Now how are the fundamental cut sets? Fundamental cut set is a set of the branches whose removal will divide the given graph into the two parts, and that group consists of, or that set of the branches consists of only one tree branch. Because in this case, if I am taking the cut here, in that case it is 1, 2, 3, it will divide the given figure into the two parts. Obviously, this will divide the given figure into the two parts. At the same time, this set consists of 1, 2, 3 branches. Out of these 3 branches, only one is the tree branch. That's why it is valid cut set, and I will name it as cut set number 1. Is it right? Now what is our first cut set? Our first cut set is branch number 1, branch number 2 and branch number 6 is our first cut set. Is it right? Similarly, if I am coming to, I have taken this tree branch. Now I will take this tree branch. If we are taking this tree branch and if I am taking the cut here, in that case we will have the 2 tree branches. That's why that is not a valid fundamental cut set. That's why I will take the second cut set here. This will be our C2. That is fundamental cut set number 2. Now here, if we are removing 1, 2, 3 branches, it will divide the given figure into the two parts. One part is this and other is the outside part. Is it right? And this set consists of only one tree branch, and that tree branch is nothing but the branch number 5. That's why its valid fundamental cut set, which is the cut set number 2, is nothing but branch number 2, branch number 3 and branch number 5 is the valid fundamental cut set number 2, that is 2, 3, 5. Now look at how will be the third cut set. I am expecting the answers from your side for the cut set number 3, because the number of cut sets is equal to number of tree branches. How many branches we have for the tree? 3. This is first branch, this is the second, and this will be the third. These are the 3 branches we have. That's why we have the 3 cut sets here. Now in this case, if we have, this is cut set number 1, cut set number 2. This first cut set number 1 is for the branch number 6. Cut set number 2 is for the branch number 5. Now we have to prepare the cut set for branch number 4. Cut set for branch number 4 means we have to remove the branch number 4 together with the another set of the branches that will divide the given figure into the two parts, and that set consists of only one tree branch. That cut set I am expecting from your side. How will be the valid fundamental cut set number 3, and which includes this branch number 4, and we should consider only this tree branch. Then I am expecting the answer from your side. I will come back to you. Now here look at how will be the cut set number 3. Our aim is to remove this branch because already we have taken one cut set for 6, one cut set for 5. This. If we are taking the cut set here, there will be the two tree branches. If we are taking the cut set here, there will be two tree branches again. But here, if I am removing this one branch, this is second, this is third, and this is fourth, means my cut set number 3 will be something like this. This is our cut set number 3. Are you getting me? This is cut set number 3. This is C3. Now look at, this is co-tree branch, this is co-tree branch, this is co-tree branch, and this is only tree branch. That's why, and if we are removing 1, 2, 3, 4 branches, we will divide the given figure into the two parts. This is one part and this is another part that I will discuss while drawing its matrix. Is it right? That's why here cut set number 3 will be branch number 1, branch number 2, branch number 3 and branch number 4. ऐसा कभी नहीं सोचना है कि इसके लिए ये कट सेट फंडामेंटल कट सेट हो ही नहीं सकता. Obviously there is at least one fundamental cut set. You see here in this particular case for each tree branch, in this particular case 1, 2, 3 and 4, this is the cut set number 3. Is it right? If we have the cut sets, then we will prepare the fundamental cut set matrix, which is the QF. Here I will start the preparation of the fundamental cut set matrix, which is the QF, which is equal to. How is this fundamental cut set matrix? The rows of the branches are nothing but the cut sets. We have the 3 cut sets, C1, C2, C3. These are the 3 rows. Then what are the columns? Columns are nothing but the branches. Branch number 1, branch number 2, branch number 3, branch number 4, this is the branch number 5, and finally it is the branch number 6. This here we have the 6 branches. That's why we will have 6 columns in this particular matrix. Is it right? This is column number 1, this is column number 2, this will be the column number 3, 4, 5 and 6, and it will be the row number 1. This is the row number 2, and it will be the row number 3. Miss, I will now find out the elements. I will find out the elements in this particular case. I will start the discussion with the cut set number 1. C1. Where is the cut set number 1? This is the cut set number 1. Now here, for cut set number 1, if we are removing 1, 2, 3, these 3 figures, how will be the remaining part of the graph? Remaining part of the graph will be something like this. If we are removing 1, 2, 3, this remaining part of the graph will be, here is one branch, this is another branch, and this is another branch. Is it right? We have removed 1, 2 and 3, means remaining branches will be 3, something like this. It is downward, this is upward, and so on. But here, in this case, the figure is divided into the two parts. This is the part number 1. And this is the part number 2. Is it right? In that we are interested. This is the node A, this is the node B, this is the node C, and finally it is the node D. Means now the figure is divided into the two parts. Now, in this particular cut set, now look at which is the tree branch. In this cut set, the branch number 6 is the tree branch. And how is the direction of the branch number 6? The direction of the branch number 6 is something like this. It is towards this A point. Towards this A point. From the C point towards the A point. Means indirectly it is from the part number 2 towards the part number 1. Because this direction is something like this. That is part number 2 to the part number 1. Means all the branch currents which are from the part number 2 towards the part number 1, that will be taken as a positive. Now, how will be the entry for the branch number 6? I will start with the 6 because it is tree branch. Its entry will be plus because its direction is same as the tree branch direction. That's why its entry will be plus 1. Means for that branch number 6, its entry is plus 1 is the entry. Is it right? Then I will check for the branch number 2. How is the direction of the branch number 2? It is again from this side to this side. Means again that entry is from the part 2 towards the part 1. Because this is the part 2 and it is the part 1. That's why its direction is from the part 2 to the part 1, which is the same as this tree branch direction, which is the branch number 6. That's why again for this particular branch, which is the branch number 2, its entry will be again it is plus 1 is the entry for the branch number 2. How is the entry for the branch number 1? How is the entry for the branch number 1? For the branch number 1, its direction is from A to D. This is from A to D. Is it right? This is from A to D, something like this. Means in this case, how is this direction? Its direction is from the part 1 to the part 2. Is it right? But which is the positive direction? Positive direction is the direction which is available for this given branch, which is the tree branch. Its direction is from the part 2 to the part A. That's why this direction is opposite to that of that direction. That's why its entry will be minus 1. Means indirectly this is tree branch, its direction is plus 1, this will be the plus 1 and this direction will be the minus 1. And those entry, this is for the branch number 6, this is for the branch number, I guess it is the 2, and this is for the branch number 1, and remaining entries will be 0. This entry is 0, this is 0, this is 0 because branch number 3, branch number 4 and branch number 5 is not the part of that particular cut set or fundamental cut set. That's why this is the entry for the cut set number 1. Now, I will start the discussion about the entries for the cut set number 2. This is for cut set number 2. How is the cut set number 2? This is the cut set number 2. This is cut set number 2. Is it right? Means if we are removing 1, 2, 3 branches, how will be the figure? First, I will draw that figure. It is the node A, this is the node B, this is the node C, and this is the node D. This is original figure. Here it is node A, this is node B, this is node C, and this is node D. This part is the calculation part, need not to do in the examination. Just try to understand this concept. So here we are removing branch number 2, 5, and 3. In that case, how will be the figure if we are removing 2, 5, 3? In that particular case, its figure will be something like this. Here will be one branch. This is the second branch. And here will be the third branch. It is something like this. Its directions are not important, but still I will draw. This is downward, this is upward, and this is the backward. Is it right? Now, the figure is divided into the two parts. This outer side is the part number 2 I will take. This is part number 2 and this portion is the part number 1. This dot or this node is the part number 1. This is the part number 1 and this is the part number 2. Now, in this cut set, find out the tree branch. The branch number 5 is the tree branch. Is it right? Branch number 5 is the tree branch. How is the direction of this branch? It is downward. It is something like this. Is it right? How is this direction? This direction is from the part number 1 to the part number 2. In that case, these entries will be taken as a positive, especially for this branch number 5. How is the entry? Because the branch number 5 is the tree branch itself, its entry will be plus 1 because its direction is very same as the tree branch because itself is the tree branch. Is it right? It is little confusing. Is it right? Similarly, if I am going for the calculation of this cut set, then we will consider the branch number 2. How is the direction of the branch number 2? It is something like this. From the part 1 to the part 2. This is also part 1 to the part 2. This is also part 1 to the part 2. That's why for the branch number 2 again, its entry will be plus 1. This is again plus 1. Fine? Yeah. For the branch number 3, how is the direction? The direction is the downward. It is something like this. This is for the branch number 3. This is for the branch number 3. How is the entry for the branch number 3? Look at it is from the part 1 towards this outer part, which is the part number 2. This direction is very same as the branch number 5 direction, which is the tree branch. That's why this entry for the branch number 1 is also taken as a +1, and remaining entries will be 0. This is 0, this is 0, and this entry is also 0. Means 0 plus 1 plus 1, 0 plus 1 and 0. These are the entry for the cut set number 2. Similarly, if we are preparing for the cut set number 3, look at how will be the cut set number 3. How will be this calculation of this matrix for the cut set number 3? For that case, I will consider the point here, that is third cut set. I will do that calculation here. How will be the third cut set? First, I will draw the nodes. This is node A, this is the node B, this is the node C, and finally it is the node D. Is it right? This is A, B, C, and D node. I will give the names to the nodes. This is A node, this is B node, this is C node, and this is the D node. Is it right? We have the 4 nodes, that is A, B, C, and D. Now what we are doing, we are removing branch number 1, branch number 2, branch number 3, and branch number 4. Remaining branches are branch number 5 and 6. I will draw the branch number 5 and branch number 6. This is the branch number 5, and here it is the branch number 6. This is the branch number 5, and this is the branch number 6. These are the 2 remaining branches after the removal of 1, 2, 3, and 4. Is it right? Now again, the figure is divided into the 2 parts. This is one part and this is another part. I will assume this is as a part 1. This part is the part 1, and I will assume this part as a part number 2. This part is the part number 2. Is it right? Always try to use this kind of the concept, because in this case, especially for this cut set number 3, the calculation or preparation of this matrix is not that much simple. If you understood this concept, then no difficulty in these calculations. Is it right? Now out of 1, 2, 3, 4, find out which is the tree branch. This branch number 4 is the tree branch. This branch number 4 is the tree branch. How is its direction? Its direction is upward. Is it right? Its direction is upward. This is for the branch number 4. How is its direction? Its direction is from the part number 1 towards the part number 2. Part 1 to the part 2, because this complete is the part 2. That's why this itself is a tree branch. That's why entry for this branch number 4 will be +1. This entry is the +1. Is it right? Then after this, I will come to 1, 2, 3, these 3 branches. I will start for the branch number 1. How is the entry for the branch number 1? How is the direction of the branch number 1? It is downward. It is downward. This direction is downward. Look at. This direction is the downward for the branch number 1. Is it right? I will check the direction of the branch number 4. It is fine. It is upward. Yes. I will check this direction. It is upward. Yeah. This is upward. Yeah. So here in this case, if we are doing this calculation, it is from the part 2 to the part 1. And how is this direction? This direction is from the part 1 to the part 2. And this is from the part 2 to the part 1. That's why this entry is opposite. That's why its sign is, it is -1. Similarly, if we are going for the branch number 2, for the branch number 2, the direction is something like this. This is for the branch number 1. This is for the branch number 2. How is the direction for the branch number 2? It is from the part 1 to the part 2. How is this direction? Part 1 to the part 2. Even though these are the 2 directions looking to be opposite to each other, but try to understand the concept. It is from the part 1 to the part 2. And this direction is also from the part 1 to the part 2. That's why the entry for the branch number 2 is taken as +1. And finally, the direction of the branch number 3 is something like this. Direction of the branch number 3. How is the direction of the branch number 3? It is downward. This is downward. But it is from the part 1 to the part 2. This is also part 1 to the part 2. That's why its entry is also taken as +1, and remaining entries will be 0. Which here, in this particular case, for these assumed directions, because in this case, this is downward, this is downward, this is also downward, it is upward, this is downward, and this is backward. For this assumed direction, this is the fundamental cut set matrix. I will come back to you and I will discuss any difficulties we have in the preparation of this matrix, which is nothing but fundamental cut set matrix. I will come back to you. Yeah. Yes, I will start with the Chaya.
Yes, sir.
Any difficulty in the preparation of this matrix, which is the fundamental cut set matrix?
No, sir.
No. Then I will come to the Navjot. Any difficulty? I will come to Ruchira.
No, sir, no difficulties.
I will unmute to Shailesh. Any difficulty in the understanding this fundamental cut set matrix? Yes. If no, I will proceed further to the next step, which is the step number 5. Is it right? What is the step number 5? In this case, I will start the discussion with step number 5 and I will show which will be the step number 5. Yes. Which will be the step number 5. Here I am back. Now here, what are the steps we have completed right now? Here we have completed this oriented graph. We have selected tree, we have prepared the fundamental cut set, and then we have prepared the fundamental matrix, which is here. The next is to construct the branch admittance matrix, that is YB. We will prepare this YB first. Then I will come to this point. Is it right? Now we will prepare the fundamental, we will prepare the branch admittance matrix. Is it right? For that purpose, I will take this figure for the consideration. This figure, because this is our standard figure. I will use this standard figure for that particular calculations. The next step is a step number 5, which is preparation of branch admittance matrix. Branch admittance matrix. This matrix is represented by symbol YB, branch admittance matrix. And what is the order of this matrix? B cross B. Here B is the number of branches. How many branches we have? We have the branch number 1, 2, 3, 4, 5 and 6. This is order will be 6 cross 6. Is it right? Now I will do the entry of the first branch. What is the admittance of the first branch? 1 more. This is 1. Then it is 0. This is 0. This is 0. This is 0. This is 1, 2, 3, 4, 5. And this is again 0. These are the entries for the branch number 1. How are the entries for the branch number 2? For the branch number 2, its entry is this 4 more. Its entry is the 4 more. That's why it is 0, 4. This is 0. This is 0. This is 0. And this 0. For the branch number 3, this is the third branch. Its admittance is 1 more. This is 0. This is 0. This is 1 again. 0, 0, 0. Then for the branch number 4, its admittance is 2 more. This is 0. This is 0. This is 0. Here its value is 2. This is 0 and 0. For the branch number 5, which is the center branch, its admittance is 10 ohm. Sorry, 10 more. 0, 0, 0. This is 0. Its value is 10 and finally its value is 0. The next, if we are preparing for the final branch, which is the branch number 6, this is 0, this will be 0, this is 0, this is 0, this is 0, and its admittance is the 4 more. This admittance of that particular branch is the 4 more, and this is the preparation of the YB, which is the fundamental, which is nothing but the branch admittance matrix. If we have prepared this YB, the next step is the step number 6, which is the calculation of the cut set admittance matrix. Is it right? Preparation of cut set admittance matrix. This procedure is little lengthy. That's why it is somewhat times it is boring. Now here the next step is the preparation of the cut set admittance matrix YC, and its formula is this YC is equal to QF into YB into QF transpose. Is it right? And this YC, its equation is this is QF into YB into this is QF transpose. This is QF transpose is the equation. I will start the calculation of this YC, which is equal to. Here, if there is a mistake, please let me know, and just point it out if I am doing the mistake in some calculations. Is it right? In some calculations, maybe. Now, I will take the QF here, and first I will write the QF. This is QF, that is fundamental cut set matrix. This is fundamental cut set matrix. How is the QF? Here, this is plus 1. Sorry, this is minus 1. It is plus 1. It is 0. This is 0. This is also 0. This is 1. Then it is 0. This is plus 1. This is plus 1. This is 0. This is plus 1. And this is 0. Last entry will be minus 1, plus 1, plus 1. And it is a plus 1. And this is 0. And this value will be 0. This is QF. Is it right? I have taken this QF into this YB. QF into YB. Is it right? I will copy that YB. How is the YB? This is 1, 0, 0, 0, 0, 0. This is 1, 2, 3, 4, 5, 6. Yes. This is 0, 4. I will copy the YB. This is 0, 0, 1. This is 0, 0, 0 again. This is 0, 0, 0. This is 2. Then 0. And it is 0 again. This is 0. This is 0. This is 0. This is 0. This is 10. This is 0. And here finally this is 0, 0, 0. This is 0. This is 0. And its value is a 4. This YB I have copied. That is branch admittance matrix. We are interested in calculation of the cut set admittance matrix into QF transpose. Transpose of this matrix QF. Transpose of the matrix QF, which is somewhere here. This is right. This first row will become first column. This is minus 1. This is 1. This is 0. This is 0. This is 0. And it is plus 1. I will check. Minus 1, plus 1, 0, 0, 0, and 1. Fine. This is 0, plus 1, plus 1. This is 0. This is 1 and 0. This is 0, 1, 1, 0, 1, 0. Next. It is minus 1. This is 1. Here it is 1. This is 1 again. This is 0 and this is 0. This is the QF transpose. I will show. This is the QF. This is the YB. And this is the QF transpose. We will find out the multiplication of these two matrices first. Then we will prepare finally the multiplication of this obtained matrix into this matrix that will give the YC, which is nothing but the cut set admittance matrix, which is the cut set admittance matrix. Now I will start the discussion here. In this case, if I am starting the multiplication from here, if I am starting its multiplication from here, look at the calculation part. Is it right? Yeah. In this case, if I am finding this YC, in this case I am finding this YC, which is equal to, this matrix will be as it is, minus 1, 1, this is 0, this is 0, this is 0, and it is 1. This will be 0, 1, 1, 0, this is 1, 0. This is minus 1, 1, 1, 1, and this will be 0, and this is 0. Is it right? Now, what we will do, we will prepare the multiplication of this matrix and this matrix. That matrix we will prepare here. The multiplication of the two matrices we are trying to prepare in this particular case. Now, in this case, if we are finding the multiplication of these two, what I will do, this column, this row and this column, this 1 into minus 1 is a minus 1 plus 0 plus 0 plus 0 plus 0 plus 0. Its first entry, it is the minus 1. Is it right? The first entry is minus 1. Then this row and this column again, this 1 into 0 is 0, plus this 0 into 1 is 0, plus this 0 into 1 is 0, plus this 0, plus this 0, plus this 0. This entry will be 0 is this value. Second. How is the third? This row into last column, which is 1 into minus 1 is the minus 1, plus this 0 into 0 plus 0 plus 0 plus 0 and so on. This is the complete row for this matrix. Then multiplication of this row and this column, 0 into this value will be 0. This is 4 plus this value 0, 0, 0 and 0. This value will be plus 4. The next, this row and this column, its value will be, this is 0, this is plus 4, 0, 0, 0, 0 and so on. This value is again plus 4. What is the next? This row and this column. The 0 into this one will be 0, then 4 into 1 will be 4 plus 0 plus 0 plus 0 plus 0. This again, its value will be the 4. Is it right? Then, in this case, multiplication of this row and this column, here it is 0, 0, this is 0, 1 into 0 will be 0, this is 0, this is 0, this is 0. This value will be 0, this value is 0. Then this row and this column, this is 0 plus 0 plus 1, 0, 0, 0. This value is a plus 1. Then third row and last column, 0, this is 0, this is plus 1, this is 0, 0 and 0. This value is again plus 1. Next, we have this fourth row and first column. This is 0, this is 0, this is 0, this is 2 into 0 is again 0, this is 0, this is 0, is here. In this particular case, this value is 0. Otherwise, we can 1, 2, 3, 4, check the fourth position, because in this row, all elements are 0 except fourth. It is 1, 2, 3, 4, it is 0, that's why everything will be 0. For the next, this row and this column, in that case, again 1, 2, 3, 4, we will check fourth is 0. That's why its summation will be 0. The next, this row and this column, this is 0 plus 0 plus 0, and this will be the 2. That's why this entry will be the 2. Next here, this row and first column, here it is 0. That's why 0 into this 10 will be 0. Remaining are already 0. Is it right? Then here, this row and this column, here is 1. That 1 into 10 will be, this value is 10. Because this again 0, this is 0 plus this 0 plus this 0 plus 10 plus 0, means that value will be the 10. Finally, this row and this column, which is minus 1 into 0 will be 0, this is 0, this is 0, this is 0, this will be 0 and this is 0, because this entry is 0, means everything will be 0 in this particular case, which is this 1, 2, 3, 4, 5, and now the last row. This last row and last column, look at the last entry, which is 1. That's why 1 into 4 will be there. That's why this entry will be 4. Then this is 0 into 4, this will be 0, and finally this will be 0. Now you are in a position to find out its multiplication. Is it right? This is the matrix, which is the multiplication of these two matrices. And if we have this matrix, we can find out the multiplication of these two matrices, and we can find out the final YC, which is nothing but Constraint admittance matrix. Now here, multiplication of this row and this column, I will write somewhere here. This minus 1 into minus 1 is the plus 1. Yes.
Sir, Raslo will be 400, na?
Just wait. I will confirm. Just wait. Yeah. Absolutely fine. Just in hurry, I have made it as a 4, but it should be 0. Absolutely correct. This should be 0. Is it right? Because this 4 into 0, this will be 4. This column and this row and this column will be 0. And again this row and this column, that will be 0. Absolutely fine. Bilkul sahi. Is it right? Now here in this case, if we have these entries, then we will find out this multiplication. How is the multiplication? This 1 into -1, that will be the +1, plus 1 into this 4 will be +4. Is it right? This 0 into 0 will be 0, this is 0, this is 0, this 1 into 4 will be +4. How much is this value? 4 plus 4 plus 1, that is 9. Is it right? This first element is the 9. Then second, this row and this column, I will write somewhere here. This is 0. 1 into 0, this is 0. Then this is 1 into 4 will be +4. This is +4. 1 into 4 will be +4. Then 0, then 0, then 0, and finally it is 0. Means it is 0. That's why its value is a 4. This entry will be the 4. Is it right? Next, if we are multiplying this row and this column, this -1 into -1 is a +1. That is +1. Then 1 into 4 will be +4. This is +4. Then it is 0, then it is 0, then it is 0, then it is 0 again. It's +0. This value will be +5. This entry will be +5. This is for this row and all the columns. I will take the second. This is for first row. Now I will take the second row. For the second row, how are the calculation? This second row and first column. This 0 and -1 will be 0. This is 1 into 4 will be 4. This is 4. This is 1 into 4 will be 4. This 1 into 1 will be 1. That is +1. Is it right? Then 0. This 1 into 10 will be +10. This will be +10. Are you getting me? This is 0. Plus it is 0. This value is 10 plus 4 is 14 plus 1 is 15. This value is 15. If I am doing the wrong calculation, just remind me. Because in hurry, I may do some mistakes in the calculations. That you have to identify. Then again, this second row and first column, this is 0. This will be the +4. Is it right? It is +4. This will be the +4. Is it right? Then it is +1. Is it right? This is +1. +4 and +1. Is it right? Yes or no? I will check this upper side. I am having little confusion. I will check. This is first, the second row and first column. This is 0 plus 4, 0, 0. This is 0. Just wait. How is the entry for this 15? First row and second row and first column. This is 0. This is +4. Fine. This is 0. This is 0. This is 0 and this is 0. Okay, fine. This will be the +4 only. Yes or no? I will take answers from your side somewhere. Yes, Ruchira and Chaya.
Yes, sir.
Yes, sir. Are you with me? Whether
yes,
this calculation, how much is this calculation?
Second row, sir, 4, 15, 5.
4?
15, 5.
This is 4, I guess.
First one is 4, sir.
Second is 15. Is it right?
15.
This is 15. This will be the 4, and if it is then 0, this is 4, this is 1, this is 0, and this is 10. Means it is
15.
This is 1 and this 10, means it will be 15. This second is 15. Absolutely fine. Yeah. Just remind me if I am doing the mistake. Unmute yourself and or raise your hand. I will come to you. Then the second row and third column, this is 0. Is it right? This is +4. Yes. This is +4. This is +1. Yes, it is +1. This is 0. This is 0 and this is 0. Its value is 5. This value is 5. 4, 15 and 5. Is it right? And then last row and first column, this is for row number 2. I will do the calculation for row number 3. If I am doing the mistake, please remind me. This is -1 into -1 is a +1. Is it right? +4, +1, +4. This is +1, +4. This is 0, this is 0, this is 0, and this is 0. This value is 5. Is it right? This value is 5. Then second, this last row and second column, this is 0, 4, 1. This is 4 plus 1. This is 0, 4, 1. Then again 0, this is 0, this is 0. This value is 5. Is it right? This value is 5. And finally, this row and this column, which is minus into minus, that is a +1, +4, +1, +4. Is it right? Then +1 again. Here is a +1. Then +2 again. This is +2. And then 0 and 0. You see here it is +1, +4, +1 and +2. Means 4 plus 2, that is 6, 7 and 8. This value is 8. You see here, this is the 8. And this is the preparation of the YC, that is the cut set admittance matrix. Now I will come to you. I will discuss the next point. We will discuss the next point. I will come to the PPDs. Here, what is the next point of the discussion? Prepare the cut set admittance matrix YC using this equation QF into YB into QF transpose. And using that equation, we have prepared this matrix 945, 415, 5, 558. This is YC, that is cut set admittance matrix. What is the next step? In this particular case, the next step is this. This is the next step. Prepare the current source matrix as shown below. And its entries are taken. What are the rules? Its entries are taken positive if the branch current and source current or current source attached to it has the same direction. If both have the same direction, then that entry will be taken as a +1. I will start the discussion of the next step, which is the step number 7. Which is the step number 7. Yes, I will come back to the camera. Here, this is the step number 7. Preparation of the current source matrix. Current source matrix. IS. How will be the IS? This current source matrix, which is equal to. Who will prepare that current source matrix? I will come to this point. Look at here. This is the figure. How are the entries for this current source matrix? How are the entries? I will show the rules. If this branch number 1 and this current directions are same, then its entry both are same. That entry will be taken as a +5 or plus its magnitude. Now here, how many branches we have in this figure? We have the 6 branches. That's why 6 element must be there in this current source matrix. For the branch number 1, both directions are same. This direction is downward and this current direction is downward. Both the directions are same. That's why its entry will be taken as a plus and its magnitude will be 5 ampere. This entry is +5. For the branch number 2, this is branch number 2. For this branch, there is no current source attached. Its entry will be 0. For branch number 3, look at, this is the branch number 3 which we have taken. Its direction is downward and this current source direction is upward. Both directions are opposite to each other. That's why its entry will be minus and its magnitude is 12 because this value of this current source is 12 amperes. For branch number 4, there is no current source attached. Its entry will be 0. For branch number 5, this is downward and there is no current source attached. That's why its entry will be 0. And finally, for this branch number 6, there is no current source attached again. That's why its entry is again 0. This is the preparation of the current source matrix, which is IS. Is it right? And if we have that current source matrix which is IS, I will show what is the next step. What is the next step? In this case, the next step is a prepare KCL equilibrium equation by using this equation, that is YC into VC, which is equal to minus QF into IS. In this case, YC already we have calculated cut set admittance matrix. This VC is nothing but node potentials, which are nothing but the cut set potentials. There is Vx, Vy, Vz, which are unknown, which we need to calculate. This QF is already known, this IS is already known. That's why I will prepare this equilibrium equation. Is it right? I will prepare this equilibrium equation. That is the step number 8. Step number 8. I will minimize this PPT and we will come back to the step number 8. Preparation of the KCL equation. Preparation of KCL equation or equilibrium equation for cut set. How is the equilibrium equation for the cut set? That equation is something like this. I will write here. That YC is equal to, or YC into that VC. This YC is cut set admittance matrix. This VC is the cut set voltage matrix, which is equal to minus, this is QF into, that's QF into IS. I will show here. QF into IS. That minus QF into IS. This YCVC minus QF into IS. This is minus QF into this IS. IS is the current source matrix. This YC. I will copy that YC first. I will copy that YC, which is the cut set admittance matrix. Is it right? Look at this. This is the YC. I will write YC first. Here it is. I will start from here. What is the value of YC? This is 9, 4, 5. This is 4. This is 15. Here it is 5. This is 5, 5 and 8. Is it right? This into, look at here how I am able to identify the error here. Generally, this matrix is a symmetry. Generally, I am saying. Which diagonal elements are different, but this element is same as this element is same as this element is same as this generally. That's why whenever we have the different values in such cases, try to identify the calculations. Repeat the calculation or check the calculations once again. That is some concepts we have. This is VC. VC is the cut set voltages. How many cut sets we have? 3 cut sets. First voltage I will call it as Vx. Second voltage I will call it as Vy. And third cut set voltage I will call it as Vz, which is equal to, this is minus QF. How is the QF, or what is the QF? QF is the cut set matrix. QF is the cut set matrix, which I will show here. This is QF. Here it is minus 1. This is plus 1. Then entries are 0, 0, 0. Just wait. Yeah. It is something like this. This is minus 1 plus 1. This value will be 0. This is 0. This is 0 and it is a plus 1. 1, 2, 3, 4, 5, 6. Plus minus 1 plus 1, 0, 0, 0 and plus 1. Fine. This is 0. This will be plus 1. This is plus 1. This is 0. This is plus 1 and it is 0. This is minus 1. It is plus 1. This is plus 1. This is again plus 1. This value is 0 and this is 0. And this is the QF. Is it right? This is the QF. Check it once again. This is minus 1 plus 1 0 0 0 plus 1. Then 0 plus 1 plus 1 0 plus 1 and 0. Then minus 1 plus 1 plus 1 plus 1 0 and 0. Absolutely fine. This is QF. Into IS. IS is the current source matrix. Already which we have with us. Which is here. This is 5, 0, minus 12, 0, 0 and 0. This is IS. Is it right? If we are doing this calculations, this matrix I will keep as it is. It is 9, 4, 5. This is 4, 15, 5. This is 5, 5, 8. And this value which is Vx, it is Vy, and this value is the Vz, which is equal to. Here this minus sign I will keep as it is, and I will find out these values. I will find out these values. Multiplication of the matrix. Now this row and this column will be the first element, then second element, and then third element. We will have three elements. How will be the values I will put here? This minus 1 into 5 will be minus 5. This is minus 5. Then 0, then 0, then 0, then 0, then 0. Means it is minus 5. It is minus 5. Then for second or first column, this is 0, this is 0, this is 1 into 12, which is minus 12. 1 into minus 12 will be minus 12. Then this is 0, this is 0, this will be 0, this entry will be minus 12. Finally, for last, this is minus 5. Minus 1 into minus 5 will be minus 5. Then 1 into 0 will be 0. This will be minus 12. This minus 5 and minus 12 is minus 12. Then 0, then 0, then 0. Means this value will be 17, I guess. This is minus 17. This value is the minus 17. Is it right? If we are multiplying by this minus side inside the bracket, then this will be plus 5, plus 12, and plus 17. These are the values. Now we have, this is 9Vx, 4Vy, 5Vz, which is equal to 5 is equation number 1. 4Vx, 15Vy, 5Vz is equal to 12 is the second equation. 5Vx, 5Vy, and 8Vz, which is equal to 17, that is the third equation. Now I will use the calculator and I will find out the potentials, which is Vx, here Vy and Vz, and these potentials are nothing but the node voltages, or indirectly these are nothing but the cut set voltages. We will find out the cut set voltages. I will use the calculator and I will find out the values. Look at here. I am entering these values into the calculator. This is 9. I will first go to the mode. I will choose the equation and then I will select the unknowns as the 3. Value of the A1 is 9. This is 4. The next is 5. And the next constant is this value, which is 5 again. Then A2, this is 4. This is 15. The next is a 5. Is it right? And its constant is 12. Then A3, it is 5. The next value is a 5. Next value is 8. And its constant is the 17. Is it right? This is first value is minus 0.98. Second is 0.18. And third is 2.6. I will check the calculations once again. A1 is 9. Yes. B1 is 4. Yes. It is plus 5. Yes. It is plus 5 again. Fine. Then its value is 4. This is 15. This is 5. The next is 12. Yes. This is 5. This is 5. Next is 8. And last is 17. That's why the first answer is minus 0.98. This value is minus 0.98 volt is the first voltage, which is first cut set voltage. Second is 0.18, that is plus 0.18 volt is the second voltage. And the third, which is 2.6. This is 2.62 volt is the third voltage. Sometimes problem may be only up to this. Calculate the cut set voltages. It will end here. But in this case, what is our question? Our question is that calculate the branch voltages and branch currents. In this case, we are interested in the calculation of the branch voltages and branch currents. Its next step will be the calculation of the branch voltage. Next point, which is nothing but the point number 9. Point number 9, I will show here how is that calculation. Now, branch voltages can be calculated by using the equation VB is equal to Q of transpose into VC, where VC is the cut set voltage, just right now which we have calculated. This equation will be, step number 9 is the calculation of branch voltages. What is the formula? Here its formula is VB is equal to this VB It is QF transpose into that VC. QF transpose into VC. Is it right? This formula is, this is QF transpose into VC, where VC is the cut-set matrix. Here I will write this matrix. How is this matrix? VB is nothing but branch voltages. We have 6 branches, means we have the 6 voltages. V1, V2, V3, this is V4, this is V5, and finally it is V6. These are the 6 voltages in which we are interested, which is equal to QF transpose of this matrix, transpose of this fundamental cut-set matrix. Now I will write its transpose. How is this transpose? I will write here. How is this transpose? -1. This row will become column. This row will become column. -1. This is +1. Then we have 0, 0, 0, and then we have the +1. This here it is +1 again. The second row is 0. It is +1. This is +1. This is 0. It is +1 again, and finally it is 0. 0, +1, +1, 0, +1, 0, fine. And this third row will become third column, which is -1. It is +1. Then again it is +1. Then again +1. Then finally 0 and 0. This into VC. VC is the cut-set voltage. Already we have calculated the cut-set voltage. Just I will show and I will copy those figures here. I will copy those figures. Just in the end of this case, we have calculated these cut-set voltages. That is Vx, Vy, and Vz. These are the cut-set voltages. Those voltages I will copy here. This Vx is minus. This is 0.98. This value is 0.18 volt. And this value is Vz, which is 2.62 volt. Or just I will not write this volt because just I am taking the figures. These are the values. Now if we know these values, then directly we can find out the voltages. I will start with the calculation of the first voltage, which is V1. This row into this column. Is it right? This row into this column, -1 into 0.98, that is minus. That value will become 1 into this value, means it is 0.98, which is plus. The 0 into this value will be 0. This minus 1 into 2.62 means it will be minus 2.62. Is it right? And if I am doing this calculation, otherwise I will complete this first. Then V2 is equal to, how is the V2? This V2 is equal to this row into this column. It is +1, +1, +1. If this value is 1 into that 0.98, it will be minus 0.98. Then this +1 into this value will be plus 0.18. Then this 1 into this value will be plus, it is 2.62. This will be 2.62. This is right. I will do this calculation later on. This is V3, third voltage. This third row into this column, this is 0. This is 0.18. This is 0.18 plus this 1 into this 2.62. This it is 2.62. This value. Then V4, this voltage, fourth row into this column. This is 0 into this value, 0 into this value, 1 into 2.62. It will be 2.62. This value. And finally V5, this voltage, this row into this column, is this value will be 0 into this. Will be 0. This 1 into 0.8, it will be 0.18 plus 0 into this value will be that 0. And finally its voltage, that is V6. This voltage V6 is nothing but last row and this column. This is 1 into 0.98, which is minus, means it will be minus 0.98 plus 0 plus 0, this value which is final value. Which in this case, this value is minus 0.98. This value is minus 0.98. This value is 0.18. This is 18 volt. This is volt. This value will be 2.62 volt. This value 2.62 plus 0.18. It is 2.62 plus 0.18. 0.18. 2.8. This value will be, it is 2.8. What is the next value? This next value is minus 0.98, 0.98 plus 0.18 plus 2.62, which is equal to 1.82. That is plus 1.82 old. This is 1.82 old. 1.82 old. Is it right? Then again, I'm coming back here. This value 0.98. This is 0.98 minus it is 2.62. This value will be this value will be equal to minus 1.64. This value is minus 1.64 volt. These are the branch voltages. And if we know the branch voltages, we can calculate the branch currents. Just a minute. Yeah. We can calculate the branch currents now. And this is the last point of the discussion in this particular case, which is the point number 10. Or it is the step number 10. That is calculation of branch currents. Calculation of branch currents. Calculation of the branch currents. What is the formula for this calculation of the branch currents? This IB is equal to, I will show the formula and I will come back to you. This is the last step. This IB is equal to YB into VB plus IS. YB into VB plus IS. Is this value is equal to, this is YB into VB plus it is IS. Is it right? IB is nothing but branch currents. How many branches we have? 6. Because this IB will be something like this. Here it is I1, first branch, second branch current, third branch current, fourth branch current, fifth branch current, and it is the sixth branch current, which is I1, I2, I3, I4, I5, I6. This is IB. Into YB. Just I will show the YB and I will copy that YB here. What is that YB? YB is the branch impedance matrix. Branch impedance matrix. Sorry, branch admittance matrix. YB is the branch admittance matrix, which is this. How are the values? Its values are, it will be something like this. I will take something like this. Yeah. Here it is 1. This is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yes, it is 1. Then this is 0. This is 4. 1, 2, 3, and so on. This is 0, 0, 1. This is 0, 0, 0. Then this is 2. 0, 0, 0. This is 2. This is 0, 0. Then this is 10. 0, 0. This is 0. This is 0. This is 10. And this is 0. And this value is a 4, 0, 0, 0, this is 0, this is 0, and this value is the 4. Just we have copied that branch admittance matrix into VB. VB is nothing but the branch voltages. Just we have calculated right now the branch voltages. I will show that those branch voltages. Now look at here, these are the branch voltages. I will copy these values. This is V1, V2, V3, just we have calculated, it is minus 1.64. This first value is minus, it is 1.64. What is the second value? 1.82. This is 1.82. What is the third value? 2.8. This is 2.80. What is the next value? 2.62. This is 2.62. What is the next value? 0.18. This is 0.18. And what is the final value? It is minus 0.98. This is minus 0.98 volt. These are the branch voltages, which is VB plus IS. IS is the current source matrix. IS is the current source matrix, which is this. 5, 0, minus 12. This value will be 5. This is 0. This is minus 12. And then remaining entries are 0, 0, 0. This is 0, this is 0, and this is 0. Means we have this matrix now. And if we have this matrix with us, we can do its remaining calculation, that is last step of the calculation, which is I1. The first current, this I1 is nothing but this row into this column plus this value, or plus or minus this value. This here, in this case, how is the calculation? Here 1 into this 1.64 means it will be minus 1.64, this calculation. Is it right? Plus this 5 plus this 0 plus 0 plus 0 plus 0 plus 0 and finally this value. Means in that case it is plus 0 plus 0 plus 0 plus 0. It is 1, 2, 3, 4, 5. 1, 2, 3, 4 and this is 5 plus 0 and plus this value which is 5, which is equal to, I will do the calculation later on, 1.64 and that value. This is I1. How is the I2? This 0 into this value will be 0. This 4 into 1.2, sorry 1.82. This 4 into 1.82, this is 4 into 1.82. This value 4 into 1.82. This value 7.28 plus this is 7.28. This into this plus 0 plus 0 plus 0 plus 0 and finally it is 1, 2, 3, 4, 5, 6. 6 entries we have taken because 1, 2, 3, 4, 5, 6. These entries we have taken. Then plus or minus this value. Plus 0 is the second calculation. The third I3. This third row into this column. This 0 into this value will be 0. This is 0. Here it is 0 plus 0 plus. This 1 into 2.80 is 2.80. Is it right? Plus this 0, this 0, this 0. It is plus 0 plus 0 plus 0 and a plus. What is this value? Minus 12. This minus 12, which is equal to, that is the I3. Next calculation we can complete, that is I4. This is equal to 0 into this value, 0 into this value, 0 into this value. Is it right? This is 0 plus 0 plus 0 this value plus 2 into 2.62. Is it right? 2 into 2.62. This is 2 into 2.62. This calculation is 5.24. This is 5.24 plus this 0 and this 0 plus 0 plus 0 plus this value which is 0 again plus 0. This is equal to, that is the I4. What is the next calculation? Which is I5, which is equal to this row into this column. This is the first 0, second 0, third 0, fourth 0. This it is 1, 2, 3, 4 0 plus. This value is 10 into 1.8. 10 into 10 into 0.18 means it is 1.8. This is 1.8. Is it right? The 0 into 0.98. This value is 0 plus this value is 0, which is equal to. Now this is I5. Is it right? Then I6 is the next calculation, which is equal to this I6. How is this? Last row into this this column. It is first 0, second 0, third 0, fourth 0, and this is fifth 0. This is 1, 2, 3, 4, and 5. This 1, 2, 3, 4, 5. This 4 into this minus 0.98. This is 4 into minus 0.98. This it is 4 into in bracket minus 0.98. This value minus 3.92. This is minus 3.92 plus this final value which is 0. This is equal to. I will work out these calculations. Here in this case this is minus 1.64. This is minus 1.64. This value plus 5 plus 5. This value will be 3.36. This is 3.36 amperes is the first current. What is the second? 7.28 plus everything will be 0, means it will be 7.28 amperes. This value plus 2.8 and minus 12. It is 2.8 minus 12. This value is minus 9.2 amperes. This is minus 9.2 amperes is the value. In this case, this will be 0 plus everything will be 5.24 amperes. This value will be 1.8 amperes. and this value will be, it is minus 3.92 amperes. These are the ways of the calculation of the branch currents using this particular method.